Hello Ruslan Malim. Today we're going to talk about a research question. Is there a salary difference between European and North American players in the National Hockey League? Let me first start with why we have chosen this topic. For decades, French-Canadian professional hockey players have faced salary discrimination allegedly because their language, history, politics, and playing style are different from the more dominant English-Canadian players. More recently, a large migration of European hockey players has found homes on National Hockey League teams. They suffer the same differences. Europeans come from a different culture, possess a different history, and speak a different language. Do they also face salary discrimination? This paper attempts to answer this question. Finding evidence of salary discrimination in the workplace is difficult. Without a measure of worth tied to a specific contribution, wage discrimination is confounded by difficult to measure differences in talent and performance across workers. However, the sports industry does not suffer from opacity of the data. Voluminous statistics on player performances are now used to show high correlations of player performances with salaries and team winning percentages. For these reasons, there have been many studies of discrimination in sports with a level of precision not found elsewhere. Most involve racial discrimination against African Americans in professional baseball, football, and basketball. In hockey, the focus is on French Canadian players, and only recently has the issue of discrimination against European hockey players surfaced. Europeans in the National Hockey League are not a phenomenon, but Europeans present in the National Hockey League was very small, at most 10%, even as late as 1989. This all changed after 1989 when the Cold War ended abruptly. The liberation of former Soviet satellite countries opened borders, and the new supply of hockey talent from Russia, East Germany, and the Czech Republic became available to the NHL. The European presence has now exploded to the level where nearly one-third of all players are Europeans. This result could be alarming and possibly even threatening to owners, players, and fans that do not want to see so many native-born North Americans lose their places on team rosters. And let me continue with the literature review. We have viewed the research and one journal article. Lastly, the research, as you can see, was published in 2019, so it's one of the most recent ones, and actually it gave us the most information. But I will start with explaining the first research conclusions. I will only mention the conclusions so that we don't waste time for explaining all the variables used and so on. Let me start with the first article. In its conclusion, it stated that after the correction of skill sets differences, it was found that Canadian forwards paid less on average than European forwards. After adding the United States versus Canadian players, it was found that Canadian forwards who play in Canada earn on average less than European forwards who played in the United States or Canada. Canadian defensemen playing in Canada earn less than European defensemen playing in the United States. Let me go with the second one. So the second one is a journal article published in the American Economist, and the result of the study show weak evidence of salary discrimination against European players, and empirical results show there is no ethnic discrimination against Europeans in the National Hockey League as a conclusion of this journal article. And the last one, which as mentioned, helped us the most. So in this article, we also found that the author suggests that this difference in salary can be caused by existence of competitive hockey leagues on the West, so that European players have bargaining power over Canadians. This literature review helped us to understand how to better conduct our research. What we can draw from last research is that, firstly, since all productivity measures were proved to be statistically significant, we can safely add them to our regression. Also, we can add more variables measuring performance in order for them not to remain unobservable factors and cause omitted variable bias. It is not that they create multicollinearity problem in this case, but by calculating variance inflation factors, we can find an appropriate balance. And now I would like Tarana to continue our presentation.
Hello, Ruslan Malim. My part concerns data and methodology of our research. So starting with the data, statistics that we found is very complex and includes more than 100 variables. It is advantage from one side, but we spend a lot of time in Excel organizing it in an appropriate way for understanding and regression purposes. Then we had to decide on our basic direction and main variables of interest that we are going to test in Stata. With this step, literature review helped us a lot because we have drawn some important ideas from previous research. So in one of the researches that we reviewed, there was an idea to look separately on forwards and defenders, meaning that to run two different regressions. The motivation behind it is that different activities are valuable for each position. So, for example, it would be incorrect to use expected goals variable both for forwards and for defenders because it's more important for forwards. Also, defenders usually spend more time on the ice, so time on ice per game variable is treated differently for them. Then, for deciding on variables which can impact salary, we used 2019 year research as a guiding example. So the variables that are used in that research are on the screen now. Games played we included in our regression. Goals per game and assists per game we decided to combine into one variable which is points per game, and points is basically the sum of goals and assists. Plus minus is important variable. It measures the general contribution of player and looks at goals and goals against when the player is on the ice, meaning that when the player is playing is on the ice for the goal of his team, he gets +1, and when his team concedes a goal with him being on the ice, he gets -1. Penalty minutes per game we wanted to add, but there was only penalty minutes variable in our statistics, so we divided it by games played to come up with this variable, and the same we did with time on ice per game variable. Shots per game we replaced with more comprehensive variable, which measures not only quantity but also quality of shots, because it is quantity of shots weighted by shot position. The next two variables, which are defenseman dummy and interaction of defenseman dummy with time on ice per game, we don't include because, as I mentioned, we run two different regressions, so it doesn't make sense in our case. Then left-handed player dummy was included, but the evidence of statistical significance of this variable is mixed in all the previous literature, so we decided to use it in order to test its significance one more time and create value. So these are final variables that we are going to test in Stata. As you see, the list is huge, but we know that some of them will be statistically insignificant as a result. That's why we start this huge list in order to shorten it later. So, and we have some advantages over previous research because we add some other variables which are not included there. Those are age, disciplined aggression proxy, height and weight for both forwards and defenders, face-off winning percentage with penalties taken for forwards, and shot blocked with penalties drawn for defenders. So age is important because more experienced players usually earn more. Disciplined aggression proxy looks at how many falls resulted in minor penalties. So more aggressive players, of course, have less potential, and it is reflected in their salary. Height and weight we use for testing their statistical significance, and we expect weight to be important for defenders because additional weight helps them to oppose and prevent goals. Face-off winning percentage is used for forwards because they usually participate in face-off. Face-off is basically when the referee threw the puck between two opposing sticks, and the player who gets the puck for his team is the winner of face-off. Penalties taken for forwards because it shows the importance of that forward for the team, because more skilled forwards actually perform penalties, and penalties drawn for defenders because when defenders are preventing goals, there is a huge probability that they can make a fall, so it shows their professional level if the amount of penalties that are caused by them is less. So, and shots blocked, of course, obviously is also important for defenders. Finally, we divided salary by 100,000 because salaries are huge, and we did this in order to have more comfortable coefficients. Thanks. Now I'm passing the floor to Muraz.
Hello, dear Professor Ruslan Aliyev. My name is Yusupov Muraz, and today I will talk about results of our project, and I will conclude our presentation. So you will see that I divided my presentation slides into two parts. The left part for results for forwards and right part for results for defensemen. We firstly regress salary 100K by each variable individually, and then we regress salary 100K by a group of these variables. So we firstly divided nationality into Europeans and North American. And North American constituted American and Canadian. We found that p-value is high. That's why we rejected H0, which states that there is a difference between North American and European. In fact, there is no difference between North American, which is one, and European. The difference is $200,000, which is not a high for salary of hockey players. For defensemen, the same thing. The p-value is high. That's why there is not a high difference between North American and European players. Then we generated right-hand people. We found that p-value is also high. That's why we rejected the difference between right-hand and left-handed people. The difference is approximately $200,000 for forwards and $200,000 for defensemen. Here, p-value is also high. That's why we reject the difference. Then we regress salary by height and weight, and we found that for forwards, the height is significant and weight is also significant. So by increasing height by one, he could increase salary by $100,000, and by increasing weight, he would increase the forwards could increase 26 by $26,000 salary. So, but for defensemen, the p-value was high. That's why we rejected the difference. Like it doesn't matter for a defenseman whether he's tall or small. So here we scattered, and we could see that by increasing heights, the salary is also somehow increasing. But for defensemen, we could not say the same thing. And for forwards, it's also by increasing weight, we could say that salary is increasing. But for defensemen, it is not the case. So we also IPANT, which is a penalty taken by this individual. We regressed that we found that p-value is significant. So by increasing IPANT by one, the salary increases by $100,000, and by increasing penalties drawn, the salary increases by approximately $200,000 for defensemen. So we also scattered I4, which is regress salary 100K by I4 percentage of winning. We found that it is significant, and by increasing percentage of winning, individual forwards could increase its salary by $1,300,000. DAP discipline aggression proxy was not significant, so it doesn't matter. Blocked number of shots blocked is not significant for defensemen, and DAP is also not significant for defensemen. So we also penalty points per game. Points per game was significant, and by increasing points per game, he could increase forwards could increase salary by 5 million, and defensemen could increase salary by 6 million. Penalties minutes per game is not significant for both. Then time on ice per game is also significant for salary of forwards by increasing time on ice. He could increase salary by $400,000. It is also significant for defensemen, which increases the salary by $300,000. It is Q, which is plus minus, is not significant for both forwards and defensemen. So H is also not significant for both defensemen and forwards, which means it doesn't matter. H doesn't matter. So GP, which is games played, is significant for both, and by increasing GP, they could increase the salary by of $40,000. So expected growth is significant. So by increasing expectation for forwards, the salary increases by one $182,000. So here we regressed salary by group of variables, and we get that the age that only weight uh, games played, then points per game, then time on ice per game, and expected goals are significant. But for defensemen, it is height, weight, um, points per game, and time on ice per game. We also calculated VIF, which is not high, which means that our regression has no multicollinearity, and multicollinearity is a problem. So I want to conclude our presentation. We did um, um, we did a lot of things, but we will improve our findings. We will try to do more in Stata in order to find high, more reliable information. Um, so thank you for listening our presentation.